Hi, you're welcome to my Day 5 coding section. And in this lab, I'll be taking you through on how you can load your library, process your data set, use your ML model. So the ML model we're considering today is the XGBoost model, which is the best gradient posting model. And then we'll be using it on our energy consumption data sets. If you're just joining us for the first time, do not forget to like, share, subscribe, and also hit the notification bell. So without any further ado, let's start coding. So the first thing we need to do, please make sure you go access my GitHub for the data sets we'll be using. And if you're still lost about what we are doing, you could quickly have a refresher class from our day 1, day 2, day 3, day 4, where we talked about the introduction to machine learning, how to install Anaconda, the necessary ML libraries. Well, gave introduction to ML. I have explained how you can process your data sets. And in our day 4, which is just the last lecture and coding section I had before day 5, I explained how you can use the linear regression and the random forest model. We were able to compare both models and see the performance using the 4 basic evaluation metrics such as MAE, MSE, RMSE, and R-square. So in this class, we'll be looking at XGBoost. And from our XGBoost, our next class for day 6 will be implementing GUI using Streamlets. So if you're interested to design your own personal dashboard, don't miss my day 6 lecture and coding section. Okay, so without any further ado, let's start. Okay, so the first thing we need to do, rename your file. So in this case, we're renaming it as the 5, and we are considering XGBoost. Okay. Okay, so if you have been joining us from day 2, day 3, day 4, day 5, and now day 5, you should know the first thing we should do. The first thing we need to do is to import the necessary libraries. And what do we have? We are going to import pandas as PD. Import numpy as np. Import seaborn as xns. Import matplotlib that pyplots as plt. So just a refresher class if you're just joining us for the first time. The pandas will be used for loading and handling tabular data. The numpy will be used for numerical computation. The seaborn is a higher level of matplotlib, which is used for visualization. That means our plot. And matplotlib is just used for plotting. Okay, so since we're talking about XGBoost in this case, maybe you've not installed it during our day 1 class. You could use this opportunity to install it. Now, let me give you 2 ways you can do your installation. I think in my day 1, I told you 3 different ways you can go about it. Maybe in my YouTube channel or in during the class R. Yes, the physical class R. I must have said so. So what we need to do, if you want to do that from your Jupyter notebook, you have to just put the exclamation mark and do pip install XGBoost. Now, if you want to do that from your command prompt, you're just going to type pip install XGBoost or your Anaconda prompt. Yeah, pip install XGBoost. Or you can also use conda install XGBoost. These are the 3 methods commonly used for installation. Okay. One more thing you can add here is, although it's optional, you could put quiet, but if you're just coding for the first time, I would say you don't need this. It's optional. So what is the function of this quiet? It's just a variable that tries to keep whatever on the installation looks like by not showing it. So it's like closing what is being installed. But as a learner, you just have to see and have idea of what is being installed, right? So I'm going to on that. So let's start running the code. So if you're running the code, all you need to do, you know the shortcut, you say Shift Enter, or you just click here. Done. Okay, so we are done with that. If you're going to have errors, you're going to see that. So this shows successful and show we are running that as number 1. Okay, so let's install XGBoost. So once you finish your installation, can you see this? Yeah, so it's telling us what will be installed. So if you have not installed it, you're going to see the packages that are being installed. But because I've installed it, all I'm going to see is requirements already satisfied. So it's telling me what I have installed. Okay, so do use with what you can see. Let's move to the next thing. So I will say something. So if I were to put dash dash part, I will not even see this. I will just say that it is finished installing. So it depends if you want to see, just comment or not. Next cell is to load the data set. And we are going to assign that to a variable df and say pd.read underscore csv. Then we have features. Yeah, so this was the data set we got during our day 3, where we talked about feature engineering. We were able to process our data through that step. So please make reference to how we came about this data set. Also, if you want this data set, please check my GitHub. You're going to see the data set there. Yeah, so I'm going to drop the link for my GitHub link in the description. Okay, so let's move on. We are going to read the data sets containing the features and the target values for energy forecasting. Forecasting also means prediction. Next, we are going to call the X features and the Y features. X features is the input data, while Y features is the target. Okay, so let's do that. We are giving big X as the variable to represent S feature. But when we want to do that, if we're taking all the data sets, we need to indicate what we don't want in that data set. And whatever we don't want in that data set, we are going to drop it. And how do we drop it? We are going to use the syntax df.drop in brackets. Why df? Df was where the data set was loaded, and for us to drop it. So if you check the data set, we have so many columns. We don't want to list all the columns. So it's easier to just drop the columns you don't want. So the columns we don't want, we use the syntax df.drop. Okay. So I'm going to drop these columns. So I'm indicating the columns now. So we have global, active power, and we're also going to drop the merge data, the merge columns, which are date time. And for us to represent Y, which is our target, we are going to specify what is that column. So we are doing that by just saying df, and then we specify. So in this case, it is actually the global active power. Oh, so please check the spelling. I think I did it wrong this time. Okay, clever. Okay, so I hope you're able to get this. So this is our target variable which we want to predict. And this is the X being the input feature where we are excluding the global active power and the timestamp being the date time. So next, train test split. So let's put that in another cell. So put as much cell as you want by clicking this plus sign, which is to insert. So our train test split is going to split our data set. So if you watch my day 4 lecture, you see where I explain, but nevertheless, I'm going to explain here. So we are splitting our data set. It is very good in machine learning that as much data set you have, you should be able to train it and you should be able to test it. Let's bring you back to university where your teacher will teach you something, give you a lecture for within 10 to 12 weeks or 15 weeks, and then you have an assessment, maybe exam, maybe coursework, maybe report. So those assessments is to test your academic performance. So the same thing in machine learning. We are trying to use these data sets to train our model, and then we are able to test the model to see what the prediction looks like. Now, for us to do our test split function, we have to split it into 4 variables. Now, you can ask why. Number one, we are dealing with supervised data sets. Supervised learning, which is a type of machine learning method. So in this case, for supervised learning, we are dealing with input and label. So it means that we will be dealing with X and Y. Now this X and Y, remember we have to divide into train and test, right? So it means that for X, I'm going to have X train and I'm also going to have X test. For Y, I'm also going to have Y train and also Y test. So this brings together 4 variables, which is S train, S test. Y train, Y test. Okay, and where are we bringing this from? So let's see the function first. So the function we are going to have will be train test split function. Now, or you could call it method. We need to put some parameters inside here. So what are the parameters? We're supposed to have the data sets, the input feature, which is S, big X, and Y. And also, we're supposed to tell what split. It means how many do we want to use for testing? How many do we want to use for training? So, like I explained in my previous videos, you could do that as 70-30%. That means 70 for training, 30 for testing. You could also do 90-10, which is 90 for training and 10 for testing. You could also run at 75-25, 80-20, as the case may be. The most important thing is at what split ratio did you get the best result? That's the key thing. Okay, so in this case, we want to look at train, the test size set as 0.2. And do we want to shuffle it? No, so we set that as 4. Well, if you want this code to work, it means that we need to put something down. It means that we need to import from scikit-learn to be able to import this train test split. So let's go there. So we are saying from sklearn, which is scikit-learn dot model. We are going to have selection, and here we have imports. So what are we importing? The train test split. Okay, so now we are going to create the DMatrix for XGBoost. Now this DMatrix is going to convert the data set into XGBoost optimized internal data structure, and it is faster and more efficient for training. So let's do that on the train and also the test data. So for the train, we are assigning the variable strain, which is SGB, representing XGBoost, the matrix X train label will be equals to y string. Okay, so let's see. So let me be a bit faster copying this and modifying for S string test, sorry. So we have S test here. Y test. Okay, so once we are done with that, we are going to set the XGBoost parameters. So let me just run this. So let's see if there is anything to modify. Okay, so we have here that XGBoost is not defined. So what does that mean? It means that we did not import XGBoost and even represent it as XGB. So let's do that. Import XGBoost as XGB. So run it again. Correct. So let's move on. We are going to set the XGBoost parameters. So assign that to the variable params. Okay. So we are going to fix in the parameters. Here, let's break it down, starting with objective. So please make reference to the lecture. I was able to break down some of the explanation for these terms, okay? Then we fix the maximum depth. How deep do we want to go? As 6. And the learning rate, which is eta, we're setting that as 0.1. You could use 0.01, 0.001, any one you want. You could just tweak and check out the performance. So let's put our subsample as 0.8. And the column sample, subsample by 3 as 0.8, and set the seed as 42. So let's run this. Okay, so once we are done with this, okay, so let me give a quick review if you're just joining us for the first time. This objective, the regression tags, it's using the square root laws, the square error laws, sorry. Why for this max depth is telling us the maximum 3 depths, and this is to help us control the model complexity. The eta here means the learning rate, which is the step size shrinkage. The subsample is the proportion of training samples used per boosting round. Then here we have the com sample by 3. This tells us the fraction of features used by 3. And then for the seed, we have the random seed for reproducibility, for us to reproduce. Now let's go to train the model. Now for us to train the model, we will train the model with evaluation history. So we are going to set the number of rounds. Okay, so let's do that. Let's do that together. So we have eval results. So this dictionary is going to store the evaluation matrix. And then we have the number of rounds set as 100. So this is the number of boosting rounds. That means the training time divided by effort. And this time, let's call the model. So we have model equals to XGBoost, train, fix in the parameters, the data, that means the train data, the number of boost rounds. So you're going to assign that with what you have given, which is 100. You will put 100 direct here. And let me break this to the next line. So we have a verse. Where we have D train, D test, a verse, result, and verbose, a verse equal to 10. So this means it should be able to print the evaluation after every 10 rounds. Yes, so that's the meaning. Okay, so let's run and see what we have. Okay, so I'm trying to check that I don't have any errors. And come what may, even if we do, we have to debug it together. It's nothing to shy away from. Okay, so let me run that. Okay, so we have here results. That's supposed to have equal to. Okay, so let's run again. Okay, good. So we have the code running. Now, while it's running, it's good to save the model. So we want to save this model because in our Day6, I'm going to use this model, save in JSON file, to be able to deploy our GUI. So this is the reason why we want to save the model. So the reason why it's very important for you to save your model. Maybe you want to reuse it. You want to use the weight, everything you've done on that model with your data set, and maybe you want to use it for deployment or anything. So it is wise to save your model. So let's save the model. What is the code? So we'll say model dot save underscore model. Now we're going to give it the name we want to save it with. So any name you like. So I'm just going to call it XGBoost Energy model, and the formats will be JSON, the file formats. So model means this model. So the line of code save model function will be able to save this model we have. Okay, so once we are done with that, we are going to run it. And we're going to definitely see that it has been saved. So for you to be sure that it's saved, can you see the running time? So it has been saved here. So confirm if this has been saved. So next thing we want to do is to predict on the test data. So we have y predict equal to model dot predict d test, which is the test data set of the DMatrix. And also to define the true label, we're going to have y true, which will be d test dot get underscore label. Now that's label. Okay, so change the B to L. Okay, so let's run this and then we go ahead to check the performance. So we are going to use the RMSE to check the performance. So nevertheless, we could use other matrices I explained in our Day4, like the MAE, RM, MSE, R square. But in this class, I'm just focusing on RMSE, okay? So we have the formula as NP, which is the numpy, which is the square root of root mean square. So the mathematical representation goes this way. So we have mid squared error in brackets y test, y predicts. Now we are going to print. So what are we printing? We are going to print what we have for the root mean square. Okay. Our curly brackets error MSE in 3 decimal places. So represent that as RF. And close the curly brackets. I think that's a typo. Okay, so we are also going to print, let's see this. So we have the tests RMSE. So we want to check this in 4 decimal places. So let's run this and see. Root mean square error is not defined. So it means during the beginning of our coding section, we do not call the root mean square. So if you joined us from the last class, you know the code we're looking for, right? Maybe something I could ask you to fix without checking. So what do you think we need to do? Think. So you could go to if you open the previous class, you're going to see what we're supposed to do. Yeah, so let me show you from Day4. We are missing this, the sklen.matrix. So we are missing that. So let's put that and run again. So you could see the results. Okay. So not necessary you should put all the matrix. No, not necessary. So you could just put just put only this one. You could remove this two. I just want to recall from the last code we had. Okay, so let's see if you want to visualize the learning curve and the future importance for XGBoost. So let's see that together. So let's start with the learning curve. We are going to say PLT dot figure, the fig size we set as 10 by 5. Like I said, you could take any size you wish to put. And then PLT.plot, we have the evaluation results. When we are talking about train, this should be a single quote. And we move on with RMSA. Then label, where we have the train RMSA. Close brackets. And we are going to set for the test. So just copy this to put for the test. So we have the test, and here we have the test. Now we are going to fix in the title, XGBoost, learning curve. The X and the Y axis, plt.x label, whichever name you want, plt.y label. So let's fix what we want. So we want to call this one the boosting rounds. And this one as the RMSA. Then we have plt.legend. And we have the plt.read through. And we have the plt.show. Now we run this. Fig size equal to, I beg your pardon. So we are going to see this curve. This is for the train, this is for the test. Very nice. And we can also see that from this reflection. Okay. So let's see the future importance. So this side is for us to plot the future importance. So we are going to say XGB dot plot underscore importance, where we have model underscore, model, comma, then the maximum number of features. So set that as 10. And let's just fix the title. So we have that as top 10 feature importance. And PLT is to show us. So let's do that. Typo again. What is missing? C. Okay, so let's go. So we are able to see the top 10 feature importance that led to the prediction of the energy consumption. And if you don't want to show this, what do you do? Let's see. Now you'll notice that you're going to have this. So this is why we must put plt.show in order to remove this text. Okay, and we're able to remove that. And how about if we say close? So what happened if we say close? You're not going to see the results. Okay, so you use plt.show to see the result. Okay, so just a summary for the Day5 XGBoost model with our feature engineered energy dataset. So this notebook demonstrates the loading and the preparation of data, initializing and tweaking an XGBoost model. And we also try to evaluate the train test plates, and also we were able to visualize the model performance and the future importance. Now, would you like to deploy what you have done from training your data set to your ML model? So just look out for my day 7. Yes, my day 7 lecture. So what's next in my video? So for video 6, I'm going to talk about model explainability. Now, not all the time though, domain experts in other field understand this plotting of graph and every other thing, or showing the matrix, they don't understand. And because machine learning has black box in nature, this is why we currently have the sharp values, which helps to explain the model, to be able to tell the domain experts in whatever sector why this prediction, what are the leading influence, what to do to increase or to reduce such influence, such contributing factors to that prediction outcome. Now, would you like to see more plots on our sharp? Do well to watch out for our day 6 lecture and also our day 6 coding section. Now, if you have stayed up to this time, I really appreciate your patience, and I believe you're able to have a full knowledge on how to work with your machine learning model, especially in the likes of linear regression, XGBoost, random forest. And this is not just limited. There could be other models. All you need to do is to call the model into your dataset. See you higher. If you're just joining for the first time, don't forget to like, subscribe, hit the notification bell so you get notified when my new video release. Okay, so thank you for watching. I'll be signing off now. Bye.